So my name is Oliver Garnatz. I'm the speaker of the architecture group Adaptive Platform, and I want to present you our thoughts on the adaptive platform architecture. So finally, we did a review on our architecture at all. Oh, So we did, is it future proven or not? So, and at the end, the result was, in general, it is. So finally, what we did is more a revamp of the adaptive platform architecture. But there was a second input from the outside always. So questions like, what is the adaptive platform all about? So on the other thing, we thought, okay, should we just list here all the different facts in a huge list? But this is not really usable at the end. Therefore, we thought a graphical representation in our architecture would be maybe a good solution at the end. Therefore, we started to regroup our logical architecture view. So there are the old candidates like the PSE51, the minimal real-time system profile of POSIX, which is the basics to get the process management, and also the C++14 standard template library. This is all the classics you know all. But we added here on the right side two new groupings. So one is vehicle services functional clusters. So these functional clusters should provide a vehicle-wide functionality, possibly covering multiple machines. This means typically that we offer the service not just for a specific platform, it's more a vehicle-wide service we are defining here. One example could be something like the, in old terms, called UCM master, so a vehicle update service. If we look deeper, so we have the platform services. So these services should specify machine-specific functionalities covering a single adaptive machine. So if you have the vehicle update, then of course we need to have for each platform, for each machine, also a UCM and client for that. And this would be an example here in this case. But we have also our platform foundation. So here, most of our functional clusters are located, and that's always platform local functionality, currently as C++ libraries offered to the applications. So here it's similar to the operating system interaction. So here we should interact with a specific automotive functionality. And we decided that quite often a C++ interface is more efficient than a services for these kind of really low-level services. It's not ready to be on a service level here. But at the end, we also ask quite often, are applications limited to just these ARA services? No, not at all. You can use any third-party library as you like in your applications, but then you are in the responsibility to take care about the automotive safety demands, about the interaction with the overall security concepts, and of course also things like portability. So without a SAR, we guarantee a kind of portability to the next platform. If you just use the ARA interfaces, if you use an own library, of course, you need to take care that this library is also available in the next platform. But as also Pingley showed, so we have also now a new clusters with standardized interfaces. So where we want to have the possibility to say, okay, we standardize the interfaces to just improve the overall interoperability. So application developers can know towards which interfaces, towards which services they can implement their applications. And the biggest example is exactly the sensor interfaces for the adaptive platform. So if we now look, how does it look here in global? So I think this figure, the left side, is quite common and quite known to many things. So but there are minor or smaller changes in there. I want to go now in detail. So the first thing is the network management. So network management was a platform service previously because we thought in the past, okay, it's a kind of service with state management, but it's not true. It will not offer services to network or to other platforms. So it's just a local functionality. Therefore, we said, okay, it's better to have the network management as a platform foundation, a functional cluster, so offering a C++ interface in future. So this is a big change. The next module I want to highlight is the raw data stream. It was already present inside the communication management specification, but we wanted to say communication management should be our service-oriented communication functional cluster. So all items in there should cover the service-oriented communication, which is one of the fundamentals of the new AUTOSAR or the new automotive communication at all. But raw data stream, it's a safe library to have good communication towards TCP, UDP, and so on, like a socket, a BSD socket implementation. But the OEM can control which port, for example, is this application should use. The sensor interfaces I already highlighted as well as Pinglay. So it's also an old specification available across several releases, but it was never put into our architecture. And this was also identified in this retrospective of our architecture. And we added here exactly a new grouping. So we maybe see that future interfaces will follow up. Also, maybe standardized applications. We said if we have such, we would also like to place it here, saying, okay, that's not a native AUTOSAR functionality, but we want maybe in future also to standardize applications. And the last thing I want to highlight in this logical architecture view is the UCM, because here it was also mixed that we had this platform service UCM and this vehicle update and configuration management, or in all terms called UCM master functionality, in one specification, in one functional cluster. But indeed, this doesn't fit well. Therefore, we split them into two functional clusters, one on this vehicle service side and the other on the platform service side. The rest is keeping the same. The rest is, I would say, was already presented in the last release event. But we said we want to show you more. What is all the adaptive platform about? So, and therefore, people ask quite often, which protocols do we support? So we thought, okay, it would be good to have here a kind of overlay to our normal logical architecture view so that you can see here the different protocols provided on which functional cluster. But of course, sometimes the acronyms are very hard to understand. S2S, so what is this? Therefore, we provide also, of course, an explanation to it saying, okay, S2S is signal to service. It's really that we have this signal-based communication, typically in CAN communication, for example, mapped to services so that you can also utilize this in your adaptive interfaces if you receive services in an HPC, for example, signals in an HPC, but also which diagnostic protocols we support and so on. And I think this list is quite interesting for you to have a quick overview which protocols is supported by AUTOSAR, because that's typically all standard automotive protocols which are needed to implement an, as of today, automotive system. Next was also that we said, okay, we need also to have this view for security, of course, because security is also very important here. So the same here. So we have a huge overview about the different security aspects. And also here we have a table giving here you more details so that the communication management supports the SecOC, supports the TLS, the IPsec, the MACsec, as we also learned just before. So MACsec, for example, is not an own functional cluster, so it's not really seen in this overview. Therefore, it was important for us to highlight it here, saying, hey, we have MACsec support, which is getting more and more important to people or to projects. So also that the execution management that we have here, the trusted platform, so that we have a kind of secure boot mechanism by this trusted platform is also important. This is also functionality where you do not see by heart. So therefore, it's important to show this in these kind of overviews. Finally, we have this also for safety done, and this is also, I think, very important, so that we have here for the safety, the different safety features. And here I want to highlight also some specific safety features. So of course, also for safety is this trusted platform important, and also here the resource groups. So this is also supported so that we can limit the resources and application process can utilize. This is quite also interesting to have an overall safe system design so that you know that further applications can start. Also, of course, in UCM, we try to have measures to say, okay, freedom from interference, saying, okay, if I update a functional cluster, something that nothing else is changed by this update. And so safe car time we also have seen, and platform health management, I think it's also well known to all. But core exceptionless API design, I think this is also a very important aspect we want to highlight here. It's not that we just have here specific core types, so it's future types of the C++ standard we derived back to AUTOSAR that we can already use them, but the whole AUTOSAR APIs are based on this exceptionless API design, because exceptions are still controversially discussed if they can be used in safe environments or not. Therefore, AUTOSAR offers always the opportunity to say, I have an exceptionless API in general, which I can use in my safety projects. So to summarize, I want to come back to this question: what is the adaptive platform all about? So in my personal and I think in many others' minds as well, it's a kind of mixed critical automotive extension to POSIX. So that's the main motivation. So it's not that we say we have here a replacement for something, but a lot of extensions to POSIX to in a mixed critical environment to allow us to define or to realize the automotive needs. This includes standard automotive connectivity, as you have seen with all these protocols. The major one is, of course, SOM-IP, but we have a lot of others. So like the intrusion detection protocol, for example, to distribute the security events, or DLT to have our logging on the network, and so on. So there are a lot of automotive protocols currently used, and this is all covered in here. But we have also a lot of other automotive specific functional add-ons. Here I want to highlight, for example, the diagnostics. With my really over 20 years experience in automotive, for example, diagnostic was always problematic in these microprocessor systems, because UDS doesn't fit to all these modern systems. We try to find here a solution in AUTOSAR, and of course you can use SOM-IP standalone. You can also use the UDS diagnostics alone just for this need. But we have also other add-ons like a safety, persistency, abstraction, and so on. All, of course, always with this automotive needs of functional safety and cybersecurity. So we have here, a lot of concepts. Also, IAM was highlighted here in the speeches and so on. So this is one of the base fundaments also with the normal APIs, so that we can really say, okay, only this process is allowed to access this specific API to do exactly here specific switches, or to renew a key, so that we have your specific applications for that kind of purpose, and so on. And finally, I want to highlight one of the biggest USPs of AUTOSAR is this EE architecture development. So what does this mean in detail? So of course, a vehicle is still a distributed system, and we have this top-down workflow. We have formal exchange formats, so that you can, in a formal way, give jobs to your sub-teams. So to tier one saying, okay, hey, you have to develop that. That's your system border. That's the services you need to offer. That's the services you can use, so that I can manage my network design. And as mentioned, this is one of the biggest USPs of AUTOSAR, and also quite unique if I look to other ecosystems available in the market. So this is the end. So thanks a lot for listening. Further information can be found in this explanatory of the adaptive platform design. I also put here the link on the homepage